All right, let's tackle a huge, kind of mind-bending question. What is a singularity? And you might be surprised, but the answer isn't buried in some super complex physics. Nope, it's actually hiding in a simple math problem. You know, the one you were probably told to never ever do. So let's do it. Yeah, it all boils down to that one question. The one your math teacher probably shut down immediately. It almost feels forbidden, right? What in the world actually happens when you try to divide by zero?
Well, here's the thing. The answer isn't a number at all. It's something way more interesting. It's this one specific point where all the nice, neat rules of math, the system we count on to make sense, just seem to completely fall apart.
Okay, so to really get our heads around this breakdown, we're not going to whip out any crazy formulas, don't worry. We're just going to use one super simple equation as our little guide to explore this, well, this very strange territory. And here it is, our rule for this whole adventure. Y equals 1 divided by x. That's it. Whatever number we decide to plug in for x, this little equation spits out the answer for y. Simple enough, right? So let's kick the tires a bit. If we say x is 2, then y is 0.5. Makes sense. If x is 1, y is 1. Okay. If we shrink x down to 0.5, y jumps up to 2. You see the pattern here? As x gets smaller, y gets bigger. It's all working exactly like it should, nice and predictable. But, now it's time to get a little more adventurous. All right, this is where the real fun starts. We're not just going to jump straight to zero. That's no fun. Instead, we're going to sneak up on it. We'll get closer and closer and see how our little equation holds up when things get weird. First, let's come at it from the positive side. So let's pick a small number for x, say 0.1. What's y? Boom. It's 10. Okay, the rule is still working. But what happens if we get even closer? Let's get really close now. Let's make x super tiny, just 1,000th. That's 0.001. I mean, think about how small that is. We're practically breathing on zero. So what does our equation do now? Whoa, look at that. Y is now 1,000. Just think about that. A teeny tiny change in x made y absolutely explode. The relationship is getting extreme. So we've uncovered this incredible trend, right? The closer you push x towards zero from this side, the more ridiculously huge y gets. It's not just getting bigger, it's literally racing off towards positive infinity. It is just exploding upwards. Okay, so that's the view from the positive side. But what if we come at zero from the other direction? What happens with negative numbers? You'll see the pattern builds up super fast here too. If x is -1, y is -1. Simple. Get a little closer, say x is -0.01, now y is -100. And if we get even closer still at -0.001, you see it, right? It's the exact same explosion, just in the complete opposite direction. As x creeps up to zero from the left, from the negative side, y just plummets. It's racing down towards -infinity. Okay, let's pause. From one side, the answer is shooting up to positive infinity. From the other side, it's diving down to negative infinity. I mean, those two answers are infinitely far apart. So what in the world is the actual value right at the point of zero? The truth is, the answer isn't positive infinity, and it's not negative infinity. The source we're looking at puts it perfectly. The answer is undefined. And this is so important. Undefined isn't just some fancy math term for we don't know yet. It means the question itself doesn't make sense. It's broken. At that one single point, the rules of our little system, our equation, just can't give us a real answer. And that, right there, that's what we've been looking for. This single point of total breakdown. This place where the rules just collapse and the result is either infinite or just broken. Well, that has a name. We call that a singularity. Okay, so we've had some fun with a simple fraction, but why does any of this matter? What does this little math problem have to do with, the real world? Because, and this is the amazing part, it's not just a math curiosity. Physicists, when they try to describe our actual universe with equations, guess what? They run into the very same problem. They find these points where their own rules, the equations for space-time itself, seem to just break down exactly like ours did. And that leaves us with a really big, kind of scary thought. We just watched a perfectly logical system completely fall apart at one single point. So it begs the ultimate question. Could our universe, the physical laws that run everything, also have a singularity? A point, maybe like the Big Bang itself, where all the rules we think we know just stop working?